So, we're talking about isosceles and equilateral triangles today. There's a lot that we can tell about isosceles and equilaterals, so hopefully we know some things already in the first section of this chapter. We talked about both of those just a little bit. So take a minute to think about what you know about either of those. If you don't know anything, it's fine. That's why it's a warm-up. Okay, great. Thanks, Griff. So take a minute. If there's anything you guys know about isosceles, if you want to draw yourself a little picture, if you think you know what that looks like, talk about that. Okay, so I'm going to draw a little diagram of each of that. So isosceles, draw two different ones. So these are both isosceles triangles. Isosceles triangles are triangles that have a set of equal sides. Does anyone know anything else about them? They're triangles. What? They do have angles. Does anyone know anything about their angles? They add up to 180, so they still add up to 180, yes?
The bottom two angles are the same.
Yeah, that's what I was getting at. The bottom two angles on isosceles, well, on these drawing on isosceles are going to be the same. We call those base angles. So those would be equal. Those would be equal to each other. So that is the case, and we'll use that. We'll talk about rules with that in a little bit. Lucas, make sure you're staying with us, please. Then equilateral. Anyone know what that looks like or is? Equilateral. All the sides are the same. So I can't even draw multiple versions of an equilateral. They're all equal sides. Yep.
All angles are equal to 60.
Yeah, and all the angles are the same as well. So we're going to go into more depth about this. But both of these are super important triangles because there's a lot of information that we can get out of them if we know they're either isosceles or equilateral. So we're going to use quite a bit, or we can like kind of solve a lot about these triangles based off of what we know currently. So in our isosceles, so we're going to start with isosceles here. So we have legs, we have a vertex angle, and base angles that we're going to discuss here. And the legs are the two sides that are equal. So the equal sides are our legs. So the legs are the two congruent or equal sides. It's easy to think about, like, we hope that our legs are two equal, like both equal lengths. Now, if you guys have ever been to a chiropractor, they probably told you your legs are different lengths, or sometimes they look like they are, depending on if your body's in alignment. I think every time I go to the chiropractor, he like tells me that's how you can tell my back, there's something wrong with my back, like, because my legs don't look like they're the same length. And some of our legs aren't. So those equal sides are the legs. If you think about it, that makes things a little bit off, and so you're always, like when I had to wear I had a boot last year, and so I was always walking like crooked, and it never bothered me until I took the boot off and walked normally. Then I was walking weird because I was so used to walking with the boot, and the one leg was longer than the other. So I had it on for a long time. So legs are equal in a triangle. Now, again, so the drawings I had up there are also isosceles triangles. So the fact that this one looks like a 90-degree angle, don't let that throw you guys off. The vertex angle is the one that is formed by the legs. Hi, he's back at one. What's it? Oh, he's back at one. Okay. formed by the legs. And then the base angles are the ones that Griffin was mentioning. He had said the angles on the bottom are the same. In this case, it's going to be the two angles that are across from the legs that are going to be equal. So the base angles don't have to be on the bottom. The ones I drew at the top of the page were at the bottom, so when Griffin said they were on the bottom, it made sense. But here, the base angles are not. They're the two congruent angles, and they're always across from the legs that are equal. So I always say that leg kind of like, almost like it's pointing to that other angle. Now, the third side of our triangle doesn't have a good name in most cases. Sometimes we can call it a hypotenuse if it's a right triangle, but we don't necessarily know for sure that this one's a right unless like we measured it or they told us that. I do want to remind you guys though that angles 1, 2, and 3 still add to 180. So that's still the case, so that's going to be helpful as we work through these. Okay? So I just printed off this little theorem here, so just the rule again. It's essentially what we're just saying here. This basically says that if I have two sides that are equal, the angles have to be equal, and then it goes the other way, that if I have two angles are equal, then I can have the sides are equal. So it's basically saying if I know it has two equal sides, then it has to be isosceles and there has to be two equal angles. But the same way goes that the sides and angles can work the same way. So all you need to know is either the angles or the sides. So our next one here is an equilateral triangle. Actually, I'm wondering, let's see. Let me really quick, do you guys have a little bit, in the margin here, let's do a little example with this before we move on. I just don't want to, I realize I don't have a ton of examples like these, so let me put one in here. So let's do So I'm telling you guys this is an isosceles triangle. So this is my isosceles triangle, and I want to find x and y. What do you think we should do here? Any thoughts? What do you think? Sam, so these two angles, what are you telling me about those? Pointing to them. What's it? Just thinking? Yeah, I was just thinking maybe you tell me what you're thinking of. Yeah.
The one on the right equals 53.
Yeah, if these are the legs that are equal, that means these two angles have to be the same. So they would both have to be 53 degrees. So we can write an equation that says 53 equals 3x plus 8. That's what I was hoping by Sam pointing this way with his thumbs, that he was telling me that. So those two have to be the same. So we're going to move the 8 over. So 45 equals 3x. And then we're going to solve. So x is going to end up being 15. Okay. How do we figure out y then? Any thoughts? Okay, go ahead. Or go ahead, Liv. Sorry.
180 minus the 53s combined, I remember that.
Yeah.
106.
Yeah, so we have to know that these will both be 53. So we have to figure out what this is by knowing the three of them add to 180. So the 53s combined would be 106. And then that together with this will help us to find that angle. So you can do that a couple of different ways. If I'm just finding y, I could just do 53, and 8y plus 10 should all add up to 180. Otherwise, you're going to figure it out what that angle is and just set 8y plus 10 equal to that. It's up to you guys. Essentially, that's what we're going to do here. This is 106. So if you did it that way, you maybe move that 106 over kind of in your head. So 8y plus 10 would have to be, what is that, 74? Yeah? And then we can find our y. So with isosceles triangles, we can figure out sides or angles based off the fact that we know isosceles triangles, the angles should add up to 180. Now the sides, it basically would be like if, so like just so you guys understand, if I was talking about the sides, if this was m and this was let's make it 18, that would just mean m is 18. So those two are just equal if I was talking about side lengths. Okay. All right, let's talk about equilateral now. So we'll flip the page. So our equilateral. So you guys said a lot about equilateral already. So essentially equilateral is basically all the sides are equal. And then there's also 3 equal angles. And since the angles add up to 180, we do 180 divided by 3, and they're all going to be 60 degrees. So equilateral are kind of nice because if you know the angle has to be 60, there's not like a ton of options for what else it could be. So this next example we're going to do here, we'll do this and then we'll take a break. This drawing is kind of strange. So like it's asking us, it's going to ask us to find different congruent angles or congruent sides depending on what we know in this little like diamond here that we have. So on this, I'm going to draw on it and then I'm going to erase, but that's the power of technology, so I apologize if you can't do that, if you want to like kind of just write lightly on it or something. All right, we good there? All right, so they tell me, so basically we're asking these 6 different questions about this same drawing. So they say if AB equals AE. So what I'm going to do is I'm actually going to help myself out with this, is I'm going to draw what triangle uses those 2 legs. So if AB equals AE, the triangle that's formed is this flat triangle up on the top up there, right? So they're saying if AB equals AE, they're asking where are my congruent angles. So what I'm doing is I'm kind of trying to take out like this off of there so you guys can kind of see what we're talking about. Where do the angles have to be then? Where are the equal angles? If those are the equal sides, where are my equal angles in this red one? Yeah, it's just B and E. And we'll just call it B and E for sake of like for just like so we're not taking time to call it like A, B, E. Technically we should be calling it with the 3 letters, but to save time and confusion, I think it's easier just to call that. Alright. So our next one here. ABF is this angle here, and so I'm going to draw this over here in a second, and AFB, that's this one. So I'm going to draw, actually my cheat here, and hopefully that'll let me do this. Slide this down. Come on. So I'm bringing that down. Come on. So they're telling us that we have 2 congruent angles. They're asking where do our congruent segments need to be then? So this is trying to get you guys to see the idea with isosceles and the sides and angles. Where would the congruent segments be if those are my equal angles? You see it? Okay, speak up please. You guys should know this. Should be kind of obvious to you. Where would the congruent segments be in this drawing, in the green one? Yeah, Griff?
A, B, and E.
So it would just be those 2. And it kind of, I mean, doing a little bit of logic that they look alike, but at the same time, they're across from those equal sides. Let's do one more together, and then I'm going to have you guys try them on your own here. So AC and, CA and DA. So CA and DA. It's that little triangle up there. Yeah, Decker? Yep, so angle C and angle D. So take a minute to look at the next 3 and see if you guys can do these. Again, I'm fine with you guys just using the single letters for the angles. See if you can try these next 3. I'll give you guys a little bit of time. And then, like I said, we'll take a break after that. You're laughing at this. What?
Jackson things for not usually gets in trouble.
That's Felipe.
Yeah.
I didn't think she had him today, so I wonder if there's a different Felipe.
Isn't he in our Spanish?
Yeah, isn't.
Oh. Oh, but it makes you laugh because it's
Yeah.
just funny when she yells Felipe.
Yeah. So, usually happens.
Alright, so did you guys do this 4th one down? So if we have AED equals DEA, what are our equal segments here?
D, A, and D.
Yeah, we got these 2. Okay. Next one, BCF. I'm running out of colors. BCF is here. And BFC, so these little triangles here. And that guy down here. Alright, so BCF, what is gonna be congruent on this one?
UCC.